Good morning, students. Welcome back to the class. Like we are doing with this operating system and this fifth semester. And yesterday we have seen regarding the course outcomes and objectives and what are the syllabus we are going to cover. Everything we have seen in the last class. And today we'll be going to look after the first unit of your operating system. So before going to the first unit of your operating systems, let me explain and or let me give you a brief introduction regarding like what is an operating system actually mean. Fine. So as you are were well aware of the definition, why? Because like yesterday we have seen many times that operating system is an interface between the user and the computer hardware. Is it not so? Yeah. And I specified you that it is not the interface between the computer, but actually it is the interface between the computer hardware. Is it not so? Yeah. So today we'll be going to deal with this introduction of an operating system. Fine. So in this introduction of an operating system, like we'll be going to see why this operating system has been used in this nowadays. And without the operating system, what are the circumstances you will be going to face, and what are the things you will be going to have when you are going to have in the operating system. All the things we'll be going to cover over here. Fine. So in this introduction part, let me explain you that. So when it is going to comes under this operating system, so operating system is an a system software. I'm telling you that operating system is a software actually. So like so I'm telling you that operating system is a system software. Fine. So here you're finding the two terms, the system as well as the software. Fine. So let me tell you what is a software. As you all know, like the actual definition of this software is like software is nothing but like as we all know set of programs, right? Like we call that set of programs as a software. So I am telling you that software is nothing but tested programs and like when the tested is programs are tested and you have to document the software. So these two things when combinedly have done, we call it as a software. Fine. Software is not just as software is not a set of programs. Software is nothing but it is the combination of tested programs plus documents. Tested program in the sense like before going to do any sort of thing, we have to test the thing. So whether it is working up to the mark or whether it is going to do as a requirement or not. So that is the tested programs plus documentation in the sense in order to use that particular software, like how to use this particular software and how to make like how to use this particular software, we have to document it. So when we are going to talk regarding the definition of a software, we have to say that software is nothing but a tested programs plus documentation. So this combinedly we call it as a software. So that is the software. And I have said you that operating system is a system software. So when it comes to the software, software is going to be divided into two types. The first one is application software and the second one is system software. Fine. So the first one is the application software and the second one is the system software. So let me give you a clear cut differentiation between the application software and the system software. And we are calling our operating system as a system software. Now I'm going to explain you like why we are calling this operating system as a system software and what are the two different softwares we are having. So let me explain you. The first one is the application software. So what do you mean by an application software? So application software is nothing but it is going to do a particular task. Application means a particular or a specific task. So based on the application, what we are going to do, we are going to make use of that particular software. So for example, if you want the examples like we are having media player. So why we are going to make use of this VLC media player? In order to have or in order to listen the songs or something like that, we'll be going to have VLC media player. Or next one is like MS Office. We are going to have MS Office. So why we are going to make use of MS Office? In order to do some task, we will be going to make use of MS Office. So what I mean to say you is application software means based on the particular application what we are going to do, we will be going to use that particular software. So if I want to do listen some songs or movies, like we'll be going to have VLC player and Windows media player, like we'll be going to have. So based on the particular task, we'll be going to make use of this VLC media player or Windows media player. Suppose if I want to make use of MS Office, so if I want to do any task, so then we'll be going to have this MS Office. So that is the application software. So application software is nothing but like when we are going to do any specific task, based on that specific task, we will be going to use a particular application. So that is the application software. Now let me tell you regarding the system software. So what do you mean by a system software? System software means, in easy words, I can say you that this system software provides platform for application software to run. This is the simple one in order to have a better understanding for the system software. So what I said you is system software is a software which is going to provide a platform for this application software to run on. So that platform which is going to provide this system software is provide. That's why we are telling that operating system is a system software but not the application software. Got it? Fine. So this is how why we are saying that this operating system is a system software. So system software is nothing but it is a software which is going to provide a platform for application software to run. So this is how this system software is, the difference between the system software and the application software is going to be working. And let me like give you a better understanding. Like I'll be going to give you some example. Uh, so so when we are talking regarding the system software, so when we are going to talk regarding the system software, uh, so as we have seen yesterday, so this is the user, and here we are having operating system, and here we are having this hardware, computer hardware comes under, like we'll be going to have the CPU processor, and we'll be going to have memory, and hardware parts are input output devices. Input output devices are still we'll be going to have printer, scanner, and mouse. So this is how the hierarchy is going to be. Let me differentiate between like what is the thing when we are going to have the operating system and when we are not going to have an operating system. Fine. This is the differentiation we can provide. So here directly connecting. Here user interacts with the operating system and the operating system interacts with the computer hardware. Here also user is going to have. So here if you have seen over here, here also the hardware devices. So here we will be going to differentiate between the difference between when we are placing the operating system and when here we are not placing the operating system. So what will be happen if you place the operating system, and what will be happen if you are not placing the operating system? Suppose, suppose here I want to make use of some printer, like a printf function. As you all know, printf function is going to print the data onto the screen, right? Here we are not going to make use of any of the operating system, right? So if user want to print some data onto the screen, what he wants to do? He want to write the printf function. But is the printf function will work over here? No. Why? Because here there is no operating system. So what the user first, what the user he has to do? He has to write code for printf. He has to write code for printf, and then he has to uh, make use of that printf function in order to print the data onto the screen. So two things he needs to do. Fine. So these are the two things he needs to do. So first of all, the thing is the user wants to have the printf function, or else if the printf function is not working, like printf function, until unless we have an interface, printf function won't work. Why? Because this operating system acts as an interface. Suppose I'm telling you that you can print the hello onto the screen without making use of the operating system also. Without the making use of operating system, we can do the task, and by making use of the operating system also we can do the task. What I mean to say is, without the presence of operating system, like what the things he needs to do is, first he has to write code for the printf function. Fine. Then he has to access the hardware. These are the two things he needs to do. So like when we are going to say that it is the printf function, it is going to be very much complicated. It is going to be very much complicated. Why? Because suppose if user want to print anything, first we can't directly write printf hello. Why? Because there is no interface between the user and the computer hardware. So computer hardware doesn't aware of what is printf. So first what the user has to do, he has to write the code for printf. He can't simply write printf hello. First he has to write the code for printf. After writing the code, he has to invoke that, and then by making use of that printf function, he has to print the data onto the screen. So that is the thing, it will be going to happen when the operating system is not present. So but when it comes here, suppose here I want to print hello. I want to print hello. So user will be going to give the statement function print hello. What this operating system is going to do is, it directly going to print hello onto the screen. Why? Because here it acts as an interface. It is a software, system software, which acts as an interface between the user and the computer hardware. So in the same manner, not only take printf. Suppose here this, when we are talking regarding the no operating system. So when no operating system is there, if user wants to communicate with the hardware device, so what he has to do, he has to he has to write the activating code to which he wants to activate the device. So this is the difference between when the user is going to make use of the operating system and when the user is not going to make use of the operating system. Fine. Let me explain you clearly by taking the real world example. Fine. Real world example. Suppose a fan is there. Fine. This is a fan, and here we are having a switchboard. This is a fan, and here we are having the switchboard. So what is the switchboard actually here? This switchboard acts as an interface between the wires behind the switchboard and the fan. Is it not? So if you on a particular switch, the fan will run. Is it not so? So that means that we can run the fan without the switchboard also. How? Behind the switchboard, you will be going to have wires. So when we are going to connect that positive negative wires, you can turn on the fan. But why we are using switchboard? In order to make it flexible, like a 2-year-old children or a 5-year-old kid and a 50-year-old people. Take the case of 5-year-old kid and 50-year-old people. When it comes with the 5-year-old kid, can he attach those wires and can he make to run the fan? No, it is highly impossible. Why? Because children are taken care very much. So that is highly impossible. If it is a 50-year-old person, okay, he'll be going to have some idea so that he can attach the wires and he can make the fan to run. But it is not the case with the 5-year-old children. He can't handle those wires. He can't attach those wires. So that is the use and importance of this interface. Here the switch is an interface. It acts as an interface between the wires behind the switch and the fan. So when we turn on the switch, backside the wires would connect together and we'll be going to have the fan in a running mode. So if the switches were not there, we have to directly connect the switches and we have to make the fan to run. So what I mean to say is, with the hardware, with operating system and without operating system, we can do the tasks. But what is the main difference between the operating system having and operating system not present? In the sense, when we are going to have an operating system, it is very much flexible. It is a very much convenience when we are going to make use of operating system. That is the major goal of an operating system. An operating system should provide convenience for the user. Convenience is nothing but the user friendly nature. If the operating system is not convenient, it is not at all worthy in order to make use of the operating system. So this is how we will be going to make use of the operating system. So if the operating system, why we are in need of operating system? In the sense, the switchboard example is the best example. So here the switch acts an interface between the fan and the wires behind the switches. So when we on the switch, backside the wires will connect and then the fan will run. So that the interface we are keeping here is a switch. So without that switch also we can make to run the fan. How? So by connecting the wires manually, we can make the fan to run, fan to work. So that is not possible for each and everyone. So 5-year-old kid can't attach those wires. In the same way, that is the more flexible thing is the operating system. So interfacing, providing an interface between the two is an operating system. So here in our computer, this operating system, what we are going to deal is this operating system is going to provide an interface between the user programs and the computer hardware. As I have said you, this operating system is a system software. So what is the purpose of the system software? In the sense, this system software, so here the user will be there and here the application program will be there. Application in the sense a particular some MS Word or MS Office, some particular application. This application, when it will work, in the sense when we are having the system software. This system software will provide a platform for this application software to run on it, and then we'll be going to invoke the hardware parts of a computer. So that is the major role which is going to be played by an operating system. I think you have got why we are going to have an operating system and why we are going to give that much importance to the operating system. So this is the brief introduction regarding why we are going to have the operating system. So you have known regarding the system software as well as the application software, and also you will be going to have uh, you'll be going to have what is the system software and what is an application software, and also you will be going to see where this system software and application software are going to be used. I mean, when these system softwares and application softwares are going to play a major role. So that is how you will be going to have this um, introductory part of an operating system. Fine. And here comes uh, the next one is the functions of an operating system. So here you will be going to have the functions of an operating system. So operating system is going to have many of the functions. Like these are the different functions that are going to be provided by the operating system. So the major functionalities of an operating system is it acts as a resource manager. Like these are all the functions that are going to be provided by the operating system. Here the operating system acts as a resource manager. The operating system acts as a processor manager. The operating system will act as a memory manager, IO device manager, storage manager, and security or protection manager. So these are the different functions that an operating system is going to provide. Fine. So we'll be going to discuss each and every function, like what is the purpose of a resource manager, what is the purpose of the processor manager, memory manager. Like all these functions we'll be going to study in separate units. So you will be going to have the process management is the separate unit, memory management we will be going to read in a separate unit, and device management is a separate unit, storage management is a separate unit, security and protection is a separate unit. So I have, there are many other functions of an operating system. Why? Like it is also handles the job accounting purpose also. So but why I am mainly focusing on this is like we'll be going to have all the topics to be covered in a separate units. Fine. Each process, each functionality is of each unit. Process management first one unit, memory management another unit, device management another unit, storage management another unit, and security protection is another unit. So these are the different units you will be going to have. So let me explain you like first thing is that operating system works as an like resource manager. Fine. Resource manager is nothing but resource management. Fine. Resource manager is nothing but the resource management. So when it comes to the resources, what are the different resources we are having? When it comes to the resources, what are the different resources we are having? So we are having different resources. What are the resources? Like we call it as a CPU as one resource, input output devices as one resource, and the memory as another resource. All these are resources. Fine. So operating system acts as a resource manager. Resources means all these are the resources. So when we are going to have different processes. So let me tell you this. So the first thing is operating system is going to act as a resource manager. Fine. Yeah. So the first one is it acts as a resource manager. So this is the first function of an, these are all the functionalities of an operating system. So this is the first function. So it acts as a resource manager. So what are the resources we are having? A CPU is one resource, and next memory is another resource, and next IO devices are the another resources of a operating system. So these are the different resources we are having. There are many different resources, like these are the some of the resources we are having. So and also we are having different users. We are having different users. Different users are nothing but different processes. Different users are nothing but different processes. So I'm telling you that different processes are P1, P2 and P3. Here these are the three different processes, and here are the three different resources. For suppose process P1 is going to make use of resource CPU. So here process P1 is going to make the user resource of CPU. And suppose if P2 also needs the CPU, what it will be going to do? It has to wait. It shouldn't be in a rest condition. Both should not work for the at the same time. So that is one of the drawback in this operating system. We have to eliminate the rest condition as much as possible. So we shouldn't go for the rest condition. So resource management, in the sense, what the operating system will do is, like, it will be going to take care of all the resources and all the processes. So which process is handling which resource? Suppose if P3 is going to handle the memory and IO is now free. So this operating system make a note of all the things, that which process is handling which resources. If any two processes are struggling for only one resource, it is the responsibility of the operating system to make the processes utilize the particular resource one by one. So that is the major functionality of the operating system. So what I said you is, operating system works as a resource manager. Resources are nothing but, for example, CPU, memory, printer, plotter, scanner, mouse, all these are resources. And here we are having three processes. I mean three users we are having. Suppose user 1, user 2 and user 3. So user 1 is going to make use of printer, user 2 is going to make use of mouse, and user 3 is going to make use of memory. So these are the three users that are going to use the resources. And for example, here the user 2 has completed his task for the memory. So he wants to store something onto the memory. So he has done saving the data onto the memory. So his task is completed. Now he wants the printer. He wants to print the particular data. But the printer is under the control of user 1. Until user 1 releases the printer, user 2 can't make use of the printer. So when this user 1 releases the printer, user 2 doesn't know it. So all these activities are going to be handled by the operating system. Operating system monitors user 1, operating system monitors user 2, operating system monitors user 3. If user 1 has released the printer, who is waiting then? User 2 is waiting. Then operating system allocate that printer to the user 2. So this is how the resources are going to be managed by the different processes. So not only three processes, irrespective of any number of processes, this operating system acts as a resources manager, and it is going to allocate the resources to different processes at one after another without any clumsiness, without any race condition. The operating system is provide the resource management functionality. So that is one of the major function of an operating system. And the second important functionality of an operating system is it acts as a process management. It acts as a process management. So what is a process management? So suppose as I have said you, P1 is one process, P2 is one process, P3 is another process. As usual, P1 is handling printer and P2 is handling the memory and P3 is handling the some uh, speaker. Fine. So how the operating system acts as a process management in the sense, suppose P1 is having the printer. So P1 is using the printer from 5 minutes onwards. P2 is using the memory and P3 is using the speaker. These are all the resources. So now P2 has completed its task. Now P2 wants printer. So P2 wants printer. So how operating system acts as a process management means, so it is not going to allocate this printer to process P1 for a long time. It will be going to set some time period. So it is going to set some time period like 6 minutes, 7 minutes time period it will be going to set. So after 6 minutes or 7 minutes have been completed, this printer will be taken out from the process P1 and this printer will be allocated for the process P2. So this is how processes are going to be managed. For suppose P1 wants printer for 1 hour, but P2 wants printer for 3 minutes. Fine. If the process management concept is not there, what P2 has to do? P2 has to wait for 1 hour. Fine. But what is the time that P2 needs? P2 needs only 3 minutes of time. But how much time it is waiting? It is waiting 1 hour of time. So that is why our operating system is going to act as a process management manager. So process manager is nothing but it is going to keep a time limit for each and every process. Suppose if P1 is handling the printer, P1 should handle the printer for 6 minutes only. More than 6 minutes, it is not going to make up the printer with the P1. It is going to hand over that printer to the P2. Why? Because P2 is in need of printer. Next, P2 completed its 3 minutes of time. Now the printer is free. P2 doesn't want the printer. Again, after completion of this 3 minutes of time, this printer again will be allocated to the process P1. Got it? This is how process management is going to be done by making use of the operating system. Resource management in the sense allocating the resources to different processes. Process management in the sense for each and every process it is going to fix a particular time limit, like whether it may be a 5 minutes, 6 minutes, a particular time limit will be there. After that time limit it is going to hand over that process that resources to another process. So these are the two important functionalities of an operating system. And another next important functionality of an operating system is uh, here the third functionality of an operating system is memory management. This is one of the important functionality of an operating system. Fine. So memory management is nothing but managing the memory. As the name itself indicates, memory management is nothing but managing the memory. Fine. So when we are going to manage the memory, like how many memories we are having, as we all know, we are going to have the main memory and you are going to have the secondary memory. These are the basic two different types of memories we are having. Fine. So here the secondary memory is large and the main memory is small. Fine. As you are well aware of it. Fine. So memory management in the sense, so managing the memory, we call it as a memory management. So suppose the memory management, as I have said you that main memory is very small. Suppose main memory can handle only 10 instructions, but secondary memory can handle 100 instructions. For example, it is not for sure. For example, main memory can handle only 10 instructions and secondary memory can handle 100 instructions. Okay, so here 10 instructions we have dumped in the main memory. So if we want to keep the 11th instruction, if we want to keep the 11th instruction, can that instruction will be fit onto the main memory? No. Why? Because the main memory capacity is 10 instructions only. So The operating system functionality is memory management. So what the operating system will do is it will be going to the unnecessary page and swap in the 11th page. So here the operating system makes use of swapping concept. Swapping includes swap in and swap out. Swap out in the sense we are removing the unwanted page. Unwanted page in the sense the instruction which is not going to be used for the long amount, large amount of time, for more amount of time, that instruction we are removing from the main memory. So how many instructions are there here now? 9 instructions. But what is the capacity of a main memory? 10 instructions. So we want 11th instruction. So then we are going to swap in the 11th instruction so that the totally 10 instructions are going to fit. So without this operating system, it is not possible. Like swap in, swap out. We call swap in, swap out as roll in, roll out also we'll be going to call. We have said already in the previous class, right? In the last classes, what we have discussed, we know the concept. So this is how the operating system is going to manage the memory. So as the main memory is small, we can't accommodate all the instructions onto the main memory. So what is the operating system will do is it is going to manage the memory. Means managing memory means whatever the instructions we are not going to use for a long amount of time, those instructions are going to be swapped out from the main memory, and what are the instructions that are useful, those instructions are going to be swapped into the main memory. So these are the two concepts when we are going to deal with the memory management. This is the main concept, and what are the techniques we are using, and how we are going to make the pages in and out, all we will be going to discuss when it comes to the memory management concept. So that is the fourth functionality of an operating system. And next one is IO device management. So here input output devices are going to be managed like printer, mouse, scanner. So all these are going to be managed. Like as we have said in the resource manager, here we'll be consider in point of the device manager. Device manager means if user one using the printer in the sense, user two has to wait. If user 2 using this memory in the sense, user 3 has to wait. So when to release and when to hand over that to different users, all will be seeing in the IO and device management. And next one is the storage management. Storage management. In this storage management, we'll be going to see the file concept and directory concept also. So as we all know, a file is a collection of data, related data. A file is nothing but a collection of related data. So all the things we'll be going to keep onto a file. Directory in the sense we all make a bunch of files and we'll be going to keep in the directory. This directly we'll be also calling it as a folder file. So storage management. So in the storage management, we'll be going to look after the file concept. File concept in the sense what are the operations that we are going to be do with the file, like creating a file, reading a file, writing a file, appending a file. All the file concepts we'll be going to see. So when we are going to write anything onto the file, how it is going to be written, all these things we'll be going to see in the storage management. And finally, the last one is protection. Protection is also one of the major important functionality of an operating system. How we are going to protect the data? By keeping the passwords. By keeping the password, we are going to protect the data. So how this will be helpful when it comes to an operating system? How it will be helpful when it comes to an processes? For suppose if you are having three processes, P1, P2 and P3. P1, P2 and P3. So how this protection is going to be working among the processes in the sense, suppose P1 is going to start from 0 to 10 instructions. P2 is from 22nd to 32 instructions are there. How it is going to provide protection and security in the sense, if processor P2 wants to execute ninth instruction, if processor P2 wants to execute ninth instruction, is it possible? No. Why? Because ninth instruction is under the control of process P1. So, by the operating system is going to provide a security for not going to be used by the P2 process. Here, the ninth instruction is not going to be used by the P2 process. Suppose P3 process contains 50 to 60 instructions. If this P3 process wants to make use of uh, 30th instruction, will it be possible? No. Why? Because this 30th instruction is under the control of process P2. So P2 has no other, P3 has no authority to make use of 30th instruction. Why? Because this 30th instruction is under the control of P2. So this concept is going to be provided by our operating system. Operating system is going to provide protection of data and also the security of the data. So protection and security is going to be provided by the operating system when we are going to take this processes, like different processes P1, P2 and P3, how many processes are there. So it is going to provide protection and security for the different processes. So these are the different functionalities of an operating system. Fine. So what are the functionalities we have seen? Resource manager. So resource managing in the sense managing the resources. Resources are nothing but input output devices, printers, plotters, memory, a CPU, what all the hardware devices we are having, all the resources we are going to be managed. Process manager. Process manager in the sense how many processors are there. Irrespective of number of processes, operating system is going to allocate a particular time for each and every processes. Beyond that particular time, it shouldn't execute. The operating system will break its chain and it is going to hand over to another thing. Memory manager. Like we are going to have different memories, main memory, secondary memory, we are going to have different memories. So all those memories are going to be handled by this uh, memory management only. Fine. This is how we'll be going to have different concepts or different functionalities of an operating system. And next thing is the goals of an operating system. So what are the different goals of an operating system? The two major goals of an operating system is the first one is the first important goal of an operating system is efficiency, and before that convenience. So this is the major important goal and this is the second important goal. These are the two important goals of an operating system. Convenience. The term itself indicates that convenience is nothing but user friendly. Convenience is nothing but user friendly, like as we have seen before, like switch example. So you can operate a fan by making use of two wires connecting directly, two wires connecting directly, you can operate a fan, and this is the first option. By the second option is you can operate a fan by making use of a switch. Fine. Which one is convenient? Obviously, the second one is very convenient. Why? Because you need not handle the wires. You can't fear about the current shocks and everything. Why? Because here, if you are switching on the switch, the fan will run. The 2-year-old kid can handle this one, or 5-year-old kid can handle this one, and 50-year-old people also can handle switch very much easily. So this is the easiest one. But when it comes to the connecting of wires, nobody will be daring to connect the wires manually until unless who are experts, they only will do this until unless they are expertise in a particular area, they only will do this, or else remaining we all will be opting for this interface, this switch type only. So this is how it is very convenience in the sense user friendly. In past years, like 92% of the world is going to be using this Windows operating system. So we are having different operating systems: Windows operating system, Linux operating system, Mac OS. So all these are different examples of an operating system. So in the previous years, 92% of the world has been using this Windows operating system. Why it has conquered almost 92% of the world in the sense, this Windows operating system has a convenience. It is very much user friendly. So without knowing the basics also, anyone can handle the Windows operating system. So that is why it has conquered almost 92% of the world population. So each and every person is going to make use of this Windows operating system. Why? Because it is much more convenient than any other operating systems. So later on, it has been decreased to 82%. Why it has been decreased to 82% in the sense, as the world is emerging towards a faster environment, like this convenience is going to be reduced and efficiency is also going to be reduced. So let me say you, what do you mean by efficiency? Efficiency is nothing but number of instructions per hour. Doing per hour, we call it as an efficiency. So efficiency means the instructions we have to be execute more and more per unit of time. So that is efficiency. This Windows operating system is going to accomplish the task of convenience, but it is not going to fulfill the task of efficiency. So due to this drawback, we have emerged the Linux operating system. Now this Linux operating system is both efficient as well as convenient. So this is the now very much trending operating system we are going to make use of. This Mac OS, we are having not that much user friendly. So this Windows and Linux operating systems are the two operating systems which conquered the whole world. So previously the Windows is going to have 92% of the world's population is going to be using this Windows operating system. But later on, as it is not going to fulfill the task of goal of efficiency, we have moved on to the Linux operating system. So this is how the two goals of the operating systems are to be satisfied. It has to satisfy the convenience and it has to satisfy the efficiency also. Fine. So these are the two different goals. So with this, we have seen regarding this operating system, what is an operating system, and what is the major part that operating system is going to deal with. And we have also seen what will happen if operating system is there and what will happen if operating system is not there. So, what is the circumstances we are going to take place when operating system is there and when we are not going to make use of operating system? I'll not say that without operating system you can't do anything. Without the operating system also you can do, but it is much more harder. Only experts can do when they are flexible. Suppose we have taken that switch example. Only experts can connect the wires and they can make fan to run. In the same manner, the persons who are very much expertise, so they can only invoke any other hardware devices without the use of an operating system. So that is the difference we have seen. That is with operating system and without operating system. And finally, we have seen the functions of the operating system. So each function we will be going to study in each and every unit. So 5 units, 5 functionalities we will be going to study. And the final thing we have seen is goals of an operating system. The two major important goals of an operating system are convenience and efficiency. Convenience in the sense user friendly. Efficiency is nothing but number of instructions per unit per amount of time. That is efficiency. So what are the examples we have seen? Windows operating system and Linux operating system. And Linux is going to have both convenience as well as efficiency. But the Windows operating system is lagging in efficiency. So these are the two different goals we'll be going to have in this Windows operating system and the Linux operating system. Fine. So with this, you will be going to conclude this session, and in the next class, we will be going to see regarding the services, what the services we are going to provide by the operating system, and what are the different things we will be going to have generations of an operating system. Everything we will be going to see over here. Fine. So with this, we'll be going to end the session. Thank you all. You just go through the videos, listen it carefully. So we'll be going to have a very better session in this virtual classes. So we'll be going to see you in the next class. Thank you all. Have a nice day.